Hi guys, today we're going to touch a very important subject, which is changing a car's wheels while it's running, and that's crucial for Linux system administrators. Let me tell you what I'm talking about. I'm going to create a file called writer.sh. This writer.sh simulates a real app writing to log files. Here I'm defining the name of the log file. This function opens the log file using file descriptor 3. We're going to use it instead of default stdout, so we can control where logs go. This sets a trap. If the script receives a SIGHUP signal, it will run the reopen log function, which closes and reopens the file. This is how daemons handle log rotation. And to simulate the action of a real app writing logs, I'm just going to write a line every half a second to app.log, so let me create it. Great. Now let's write some logs. I'm going to open another terminal. Let me see how big is this file. Okay, not big. This is dangerous. At some point, the simple logging app is going to consume all of my disk space. What can I do? I'm going to show you how you can transfer the file logging to another file, and then we're going to get this old .log file, and we can achieve it and store it somewhere else. First, I'm going to rename this app to app.log.1. Now I'm going to create my new app.log. At this point, app.log exists, but the script is still writing to the renamed file, app.log.1. Why? Because processes don't actually write to a file name like app.log. Instead, when the script first opened the file, the operating system gave it a file descriptor. In this case, the file descriptor 3 that we specified in our script. This points to a low-level structure called inode. The inode is like the true identity of the file on disk. It holds the file's content, size, permissions, everything. So even when you rename the file, the inode didn't change. So the script is still writing to this file and not this new one. This new one is empty, as you can see. But we want to get this file, zip it, and store it somewhere else, and start writing to this file. How are we going to do that? I'm going to run the elseof command. This command is essentially going to tell me what process is connected to app.log, to the inode of app.log. And I got this process. I copied that process ID, and I'm going to run q.hop and the process ID. This essentially, it's going to make the writer stop writing to app.log.1, and it's going to open the file again. This sends a signal telling the script to reopen the log file. And since we set up the trap on the script, it actually does. So it's going to stop writing to app.log.1, and it's going to reopen app.log on a new inode. And now we can attest that the script stopped writing to this file on that time. And I know for a fact that the first line in this app.log is going to be 11:59. No line is going to go to waste. And here I have it. So here you go, no downtime. The logger is still writing logs. Now I can zip this file and store it somewhere else. And I have this new .log file getting logs from my app. Well, at some point you're going to have to do it again. At some point it's going to get huge. And you're going to have to do it again and again and again. Or you can set up a script on your Chrome tab that is going to do this automatically.